Subject: Microplastics and microfibers, defined by being less than 5 millimeters, are polluting the oceans and causing harm to both humans and marine life who unintentionally ingest them. One method of ridding the water from these harmful materials is using a ferrofluid and a magnet. Ferrofluid is a magnetic liquid created by suspending iron oxide in oil and water. Because of van der Waals forces of attraction, the particles bond with the oil instead of the water. A magnetic field then can be applied to the ferrofluid, which attracts the particles along with the oil as well, effectively separating them from the water. This is a video of the method I talk about in my testable question. So they removed the oil and the particles along with the plastic by using a magnet. So how effective is the ferrofluid and magnet extraction method on microplastics and microfibers of varying densities? The plastics and fibers that I'll be using all have different densities, which I predict will affect their ability to be extracted from the water. When placed in the water with iron oxide and a magnet at the bottom of the tank, the plastics and fibers will be separated by density by using magnetic density separation. This is a diagram of what will happen. So this diagram shows it on the horizontal while mine will be on the vertical. The microplastics and microfibers will mix with the ferrofluid, which is iron oxide and water. Then the plastic and fibers will split into their respective densities. This is because the magnet here creates a sort of artificial gravity where there will be higher density of water closer to the magnet than further away. This is because the iron oxide is attracted to a magnet, increasing the concentration/density in areas closer to the magnet. So the particles and the plastics and fibers with higher densities will be closer to a magnet, while the lower density plastics and fibers will be further away from the magnet. Plastic and fiber shreds will float at the height where the effective density is equal to their own density. So in my tank, it would be higher density plastics fibers down here, while lower density plastics fiber up here. And then to extract the plastic and fiber pieces, a magnet at the surface of the water will be used. If polystyrene foam, polyester fiber, polyamide fiber, and high-density polyethylene were placed in a ferrofluid and extracted with a magnet, then the extraction percentage would be 80%. But the fibers would be the hardest to remove because they are denser than plastic, meaning that they'll be further down and further away from the extraction magnet at the surface. This research could reveal an effective future method of cleaning up the oceans and ridding them of the trash. This method could also be used in a filtration device to rid the tap water of lingering microplastics. Using ferrofluid and magnets to sort plastics by density can be very helpful when recycling. Similar density plastics have similar properties, meaning that they can be recycled together. To be made into another product, plastics need to be sorted by type because combining different types of plastics make them useless for manufacturing. Using magnetic density separation will be a quick and effective way of sorting plastics. So I already explained my procedure in the previous slides, but each type of plastics and fiber will be assigned a color and then dyed with non-washable paint/dye to make them more easily identifiable. Each plastic and fiber will then be shredded into pieces smaller than 5 millimeters to be considered a microplastic or a microfiber. Then each plastic/fiber will be masked, and then all the plastics and fibers will be masked together. The iron oxide, the plastics, and the fibers will then be mixed in a tank of water. Then 3 circular magnets will be placed at the bottom of the tank, which then creates the effect for magnetic density separation. So after the plastics and fibers are separated by density, another magnet will be drawn across the water's surface to collect the material with the lowest density. For the next density level, 2 stacked magnets will be used to extract the plastics and fibers at that level, and this will be done for each density level. So all the material will then be separated into different bins based on their density, and then it will be left to dry for 24 hours. After 24 hours, each type of plastic and fiber will be remasked, and then all of them will be masked together. Then mass percentage will be calculated to determine the extraction percentage. So higher mass percentage means higher extraction percentage.